on the corner, basically. 11:30 to 12:30, pizza and prizes. And they say here, relevant for all students from freshmen through seniors, especially relevant for juniors. I think they actually mean, I don't know where you are exactly, right? You're kind of like sophomore, juniors, basically. So you're like the perfect audience for this. And they say they basically cover preparation, interviewing, negotiating for internships, in particular for them, but in general for everybody, and how to get that engineering internship and leverage it into a full-time job. So if you don't already have a full-time job or don't have an internship lined up for next summer, so it sounds like a good thing to go give it a try. I have a whole bunch of things you can look at and then throw away, apparently. You come up later and just grab one of them. So, I would say these things, there's like probably, these are not cheap to print, so anyway. All right. I also just got an email from GitHub saying they had a survey of people that had used GitHub. I think somehow it's GitHub Classroom, and then people who are graduated. Anyway, they had some stats, and I thought they were sort of interesting. So what are the stats? Here are what people are doing now. I know it's a little hard to see down here. Consulting, data analytics, healthcare technology, information technology, media, retail, e-commerce, software as a service, other software, web development, other. All I'm trying to say here is that people doing, well, apparently who use GitHub were mostly, CS and IT type people, have a fairly broad number of categories your job may end up in. They were interested in what IDE they use, and Android Studio, Eclipse, good old Emacs, 5%. Man, Vim is really kicking their, 32% for Vim. Visual Studio, but then Visual Studio Code is 50%. That's a lot. Xcode's kind of low. Here's Atom, 20%. Same as like PyCharm or Notepad++. I don't know. Anyway, some representation. I was a little surprised not to see Qt Creator on there. I feel like it's pretty widespread, but maybe it's a more niche C++, primarily IDE.
Can you scroll right? Is it the furthest one?
Other. That's Qt Creator right here.
I'm hoping that the Qt Creator.
Yeah. How do people communicate with your coworkers? Slack, big one. And maybe not surprising if you survey GitHub users, 60% GitHub. Trello, everybody uses Trello. Jira. I don't know what Confluence is. What's Confluence?
Confluence is like it's like a website that stores a bunch of articles. Like we use it for documentation, like how-to articles or like client information, that kind of thing.
Okay, so it's like a professional wiki. Okay, yeah, okay, so it's interesting. It's sort of like what's the name on here? I think I'm trying to think. There's some other tool I haven't used in a while. I used to use it quite a bit, but sounds like that. And then languages people are using or have used. That's sort of a pretty general thing. Have used, right? HTML. Man, I think HTML5 would be a little comfortable with that, but just plain HTML, I get a little nervous calling it a programming language. JavaScript is up there. CSS, style sheets. Anyway. Java, Bash Shell, Python, R, little R. C#, hey, you team C# people or whatever. Because here's C++, 50%, yeah! And C. And other. I guess Rust is still there and other somewhere. All right, anyway, nothing too dramatic, but it's kind of interesting to see what people are, where the patterns of the population are using tools and languages and so on. Any comments on that? Questions? I don't have any answers, but yeah.
Where did you get these starts from?
So there was some GitHub education or GitHub Classroom report. So there was some survey they did, and they emailed it to me because I guess I'm part of an organization for GitHub Classroom.
Oh, okay.
So I don't know, if you Google it, I don't know if you find it or whether I'm part of the secret inner circle or whatever. Anything else? All right. Today, a little C++. They're going to talk about the next part of the sprite editor, and then have some time for you to get your teams. All right? And we already looked at the classroom report. So let's talk about, we're getting questions on these software requirements. And let's say we're trying to describe the frames per second control on the playback. So the preview that cycles through the animation is supposed to have some kind of control that lets you set the frames per second. Here's some options. So read those, and let's talk about it. So if you had to pick one to put in your own software requirements document, which one of those do you think is the sort of the best way to describe what you're doing?
I'd say 2 because 2 is specific, but not like too specific. It's like specific but readable by someone who doesn't know the inner workings of your code.
Yeah, so in particular, if you're going to say something's wrong with this one, what's wrong with this one? Not that it has too much detail, but a certain kind of detail.
It doesn't specify like how you're changing. It specifies what you're using to change the FPS, but not the ways in which you're changing.
It's more of an implementation description than a functional kind of description, right? And this one just says there should be a slider, doesn't say anything about it. So it's not enough detail, you're saying, so it's too little, too much of the wrong kind of thing. And then this one, says something about what you're expecting, the range of frames per second that are allowed. And, even ticks labeled every 5 frames per second is not really should be part of that at this point, but it's still, I think, a better choice. So, comments on that, or questions, or? Yeah.
How if we say it should be labeled every 5, and then we have to stick to that, like in the waterfall method, or can we change that so it's something that's small when we're working on the project?
So I think you should be able to change it. I mean, if everything you do is like change the end, that's a bit of a problem, so you didn't really think it through very carefully, but if you have to change some stuff, I think I'm having trouble with it. Yeah. Anything else? But try to put yourself in that mindset a little bit. Don't just say we need this thing, and don't say we're going to use a Q button to do it. Kind of say a little bit about what it's supposed to be able to do. Now I want to talk a little more about, again, for this project, I'm not really saying the model and view should be completely firewalled from each other, but there should probably still be somewhere like a model, and somewhere there should be something to a view. And those, if we're organized around classes, that's all the better. If you're making a UML diagram and it has something that looks like this, with a bunch of little tiny boxes coming off this big center thing, you should think about splitting this into pieces, right? This is probably, this class, whatever it is 2 monolithic. If you just put everything in there, like this is going to solve all my problems. It's an easy way to think about it, but you're not really thinking about how to split it up so that your team can work on different parts of this. So be careful if your UML thing looks like the big chunk thing in the middle, and then just sort of nothing that's going around the side. And try to split this thing into 2 or 3 or 4 pieces and see if that helps. But in particular, if we have some kind of sprite that, you think of a sprite as some sort of sequence of images, this might be like your model. And then there's your application that has views of this model. And so maybe there's a frame editor that's showing one particular image out of that sequence. There's some sort of showing the different frames that are available, and you can add and delete them and duplicate them and do stuff down here. And there's this thing up here that cycles through the frames some rate to show the preview, right? These are all things, something like this is something what you might be developing, hopefully. And hopefully you maybe even sketched out something a little bit like this that kind of helps solidify your thinking about what's going on. But notice, these are all different ways of viewing this same data. So you don't want to copy in a bunch of frames into here, and then copy in a single frame here, and copy in another thing here, and then synchronize back and forth as different things happen. Think about just trying to use this thing, and the way you display it changes in each one of these different areas, right? That is the value of having your data pulled off into one spot as opposed to spread throughout this application. So if this is one big application and you start, I'm working on this one, and I'm going to take it out of the vector images and put it back in, and anyway, it gets very complicated trying to figure out how to arrange all these things. So try to think of this instead as you have one set of stuff. These are not sort of these are not very different. They're just different ways of examining that one thing. And I think if you get that mindset, things will go a lot easier for your architecture. So any comments on that or questions? So those are sort of my hints, Big monolithic classes, beware. If you're not kind of thinking of this duality, you can also run into some issues. Now here's another little thing I ran into. So what's your favorite? I know it's hard to choose. What's your favorite C++ language feature or chunk of code or something? What's it when you use it and you go, wow, that's great? Okay, I knew I had a taker here. Extern-C? What's that? Extern-C. Okay, all right.
I like how it's easy to decide between passing by reference or by value. You don't have to do anything weird. It's just kind of intuitive.
All right, so you like having the control over how values get passed into a function or method. I agree. I think it's explicit, right? It conveys the intent of what you want to have happen there.
I like lambdas, especially with Qt.
Okay, so lambdas again are sort of unnamed functions you define in place, and we haven't really talked about them, but I'm glad you like them because they're fun. Anybody else happen to have a favorite feature? What's mine? I didn't think about it. I don't know.
I think that's cool that you can increment chars and stuff.
You like the data types being sort of loosely interchangeable kind of things. All right. Well, here's someone, sort of a big British C++ person, who likes the curly brace. And the reason is the C++ rules and block scope of objects provide the hooks for deterministic finalization, in other words, lifespan of objects. I miss this automatic and non-intrusive management of resources when I'm using other programming languages. So I find this kind of hilarious because most people would say, what do you not like about C++? It's like, I don't like the fact that I can't control when objects live and die because you knew them and you have to delete them, and it's kind of confusing. But this person is basically saying that C++ actually does a really good job of doing this. And the reason is because, again, when you make a class widget that has a gadget inside it, then the gadget's lifetime is tied to that of the enclosing class. Basically, and when you delete the widget, the gadget goes away as well. And when you make this widget here and leave scope and curly brace this person was liking so much, it gets rid of W as well as G. And yeah, okay. So basically, these little scope, these code blocks with the curly braces gives you a lot of power as to determine when things live and die. And in some ways, like in Java, it's harder to say when something lives and die because if you return W, you're not sure if it's propagated with a reference count outside of the function or something. And some people like that you don't have to worry about it at all, but other people don't like the fact that it's hard to know when it actually lives and dies. So, for example, if we have a vector of ints, we can put them on the stack because that's where that's the life scope of that particular object. And again, stack allocation is very efficient compared to heap allocation. And if you look at something like an array of something in Java, on the stack is that reference to the array, and on the heap is an allocated chunk of references or pointers essentially to the other things, and those objects can be scattered throughout memory, right? So there's a sort of fragmentation that happens, and a lot of the stuff happens on the heap. For C++ arrays or vectors, if we know anything about it, it can be here on the stack. or it could be at least in contiguous memory on the heap. And so it doesn't seem like that big a deal. Like, why bother thinking about it? Okay, we got this again. I read an article of this guy doing a game engine, and in the game engine they have like physics objects and render objects and these entities that are made up of those things. You basically update the physics and update the rendering, so you're looping through these entities, right? And he restructured it to basically make those subparts all be one big contiguous vector. So all the physics things are next to each other in memory, and all the render things are next to each other in memory. And the game entity just basically points into those vectors to show what's going on. And basically found the code got like 50 times faster by doing this reordering. And that's because if you put all the AI things together, as you loop over the AI things, they're all next to each other in memory. The physics objects are all next to each other in memory. You load them in, they're cached somewhere on the CPU, and you kind of whip through them really fast. Whereas if each entity has its own little chunk of memory, and you say for entity 1 do the physics, and entity 2 do the physics, and entity 3, they're basically paging in and out of memory a lot. And anyway, that can have significant performance benefits. Now, I kind of hate to, I don't really like to sort of behind the scenes thinking about optimization too much, but there are times when, you want your game engine to run fast, and 50 times it has to be speed that it's good. And C++ gives you the ability to control some of that. And other languages don't really give you that control. Like, you just can't even make that choice. So even if you decide, like, overall we're slow because of memory consistency, then you don't have any way to fix it, whereas in C++ you can kind of do some things to work around that. So anyway, there are things about the way C++ decides to store objects and put on the stack or heap and so on that really can give some big wins. All right, so anybody have experience doing anything like, this kind of optimization and something about this, or questions, or? Yeah.
I had a question. So in Java, in Java, if you were to store it on the heap, it would just place it scattered, and then for C++, it's always
well, it's not necessarily scattered, but there's no
order.
It's not really a guarantee of being contiguous or anything like that.
But for C++, it's always continuous.
Well, what's inside a vector, for example, is a pointer to a heap allocated chunk of memory that is continuous.
Oh, okay. It's just whatever's at that point.
And so it does have some stronger guarantees that way. Okay, so kind of said about, the nice life cycle, C++, things go away when you hit the end curly brace. Still, and this is a very fair criticism, a major source of bugs in C++ is memory management. And so when you make something on the heap, like a new int, you must explicitly delete it at some point, right? And why is that hard? I mean, I say like this, and this is like, how dumb do you have to be to mess this up, right? You make something, and you delete it. But this is kind of understating the complexity of this. Why is it sometimes a hard issue? Like this case, you have a function and you make an int and you get rid of the int at the end of the function. It's not hard, right? So where does this actually become tricky?
Yes, when you're kind of swapping pointers, or when you're having like a temp, or like when you're returning pointers, swapping and returning. It's kind of tricky when you're deleting.
So I think in particular you said like returning a pointer. What does that mean exactly? What do you think? Where does that come up? You have some function and you're passing on a pointer to some object from that function, and someone calling that function is then capturing that value and doing something with it, right? And so why is that hard? Or what is that? Someone else give me some thought of this or something. Yeah.
Not really knowing when you're going to need to use the object of the pointer, like if it needs to transcend various functions instead of just being used in one.
So you got to pass it around. And,
yeah, it can be kind of confusing to keep track of it.
Yeah. But if you just say like make an object, so I have a pointer, and I call something with that pointer, and I call 2 with that pointer, and so on. That still doesn't seem all that hard, but there's a situation I think where, in that direction, where it really does get a little more confusing. So, at some point, what if I had pointer 2 equals pointer, and I call 3 with pointer 2. Now there's 2 pointers referencing the same underlying object, right? And then you start to wonder who actually owns this object at this point, right? Like who is responsible for deleting it? Is it the first person that made it, or there's one that grabbed another reference to that object, or there's nothing that explains to someone looking at code who is ultimate responsibility for this object. So when there's two pointers both from the same object, just because you're done with it for pointer 1 doesn't mean you can delete it, because pointer 2 maybe needs it or not. You just don't really know. And so there's this problem of sort of ownership and who's responsible for it, and it comes from passing things around functions and so on. But anyway, it gets unclear. So, deleting it twice is bad. We're all run into that, where we delete it and then delete it again, and it crashes. And not deleting is bad because you get a memory leak, and eventually you fill up with it. So, for example, if I have a function, build a house, that returns a pointer to a house, who is responsible for the object that this thing made, right? Maybe there's some comment in the function header or something that says, hey, once you grab this, you're responsible for it, so on, but we don't really know where this house pointer comes from. Maybe there's some other internal store that gets shared among, anyway, it's just hard to know what the intent is here. And comments are not a good mechanism for expressing that. Java has a similar lack of expressiveness. It basically says, well, we're not even going to worry about it, but as soon as no one cares about it, we're going to delete it, but not until then. So it's not until all the references go away, that object sticks around, which doesn't really tell you about who's responsible for it. It's just sort of, we get tired of that object and we get rid of it. It's not the most expressive mechanism. So in C++, there's a lot of rules of thumb for how you should sort of manage these resources. One is if you put something in a container, that container is responsible for it. That's sort of the implied understanding there. So you make something locally, put it in a container, the container lives on, and the container is the one that manages that resource. Another one is this idea that you should have resources that are wrapped into classes. And so if you're newing or deleting something, you should never do that sort of in a raw way inside a function. You should make a class that handles that for you. So when you construct the object, it also constructs the underlying resource. And when you delete the object by going out of scope, presumably, it also deletes that object. And finally, there's this idea now of using smart pointers, which can we augment the idea of a pointer to handle some of this for us, in sort of like a Java sort of way. But it's a generalization of this idea of basically making something to wrap that resource for you. So we'd like it to act like a pointer. So we want some class that somehow you can dereference and use arrow notation like a pointer to get to underlying methods. That basically but deletes the resource it has when it goes away. So we can, what is this going to look like? It's probably going to be a template thing, and the template's going to be whatever it holds. And here we're going to basically, we construct one by passing in a new resource to it, and then it's going to control that resource for us. So we use new here, and it's going to delete it after we do something. Actually, I got to tell you a little story here. So the other class I'm teaching right now is called Programming for Engineers, and it's a C++ class for sort of more novice programmers than you. And this just reminded me of that. So we're using this timer thing we're doing in Qt. It's something called the Q-elapse timer. It just counts at milliseconds. And I pointed to some documentation in Qt, and it has like a Q-elapse timer, and then the timer start, and then it said something like do something, and then it said timer end, and I was like, okay, that shows you how to use this timer thing. I'd like half the class tell me I try to compile it and then do something that says undefined reference, basically. And I'm just like, that is just an example. You put your own code in there, you freaks, you know? Like, oh, and I was like, anyway, just banging my head on that. So. When I saw that, I had some flashbacks on this. Okay, so auto pointer is now a deprecated part of C++. C++ 11, basically. So this was an early idea of a smart pointer of some kind, and now they have a new set of them. They do a little more for us. But let's talk about it just briefly. We want something that acts like this. It's a templated class. It takes in some heap allocated object, and then when P here leaves scope, it also deletes the thing that it's holding inside it, right? So you could actually write this class or something pretty close to it. It's a template class, and then name auto pointer, and it holds a pointer to this class, and you build one by passing in a pointer from new, presumably, and on the destructor for this thing, it deletes the pointer for you, and if you dereference this object, it dereferences the underlying pointer to the thing instead, and if you use the arrow operator on it, it basically returns. So this is actually a little weird subtlety of C++. So if I make one of these objects, what did I call it over here? P. So P is one of these auto pointer things for a class. And I say P, and let's say this is like a type sphere, so it's going to hold spheres for us, right? And then I say P dot volume or arrow volume. But this is not volume is a method of sphere. But P is one of these weird templated auto pointer things that holds spheres. We want this somehow to work, right? And I'm claiming that you can do this by just returning the pointer itself. So the result of this operator is to return a underlying sphere pointer. This arrow notation has some weird semantics. Basically, if you call arrow operator, it calls it again on the thing that's returned, in other words, the sphere pointer, until you get to some base class that actually knows how to handle it. So there's sort of this weird recursive uses of arrow that goes down through your fake classes until it actually hits something that understands what an arrow operator does, and then it applies that to the actual pointer, which is like a weird behavior, but I guess necessary for this kind of stuff. All right, so we just have a class that holds this pointer and deletes it when it's done. So that's nothing too tricky. We don't have any rule of tree stuff, even though we're managing a resource. So we have the destructor done, but we don't have a copy and assignment operator. And the problem is, this auto pointer is basically supposed to specify who controls that underlying resource. So if I have auto pointer P2 equals P, the semantics of this is supposed to mean that the underlying sphere in here is transferred to P2. And similar with assignment. So you can, it's not that hard to write a copy constructor that does that. It grabs the underlying resource from P and puts it into the new one and deletes the old, or sets the old one to null. So you can make your constructors do the proper behavior for this. So an auto pointer is one that, again, it basically says, I own this object. It's not yet shared among multiple things, but we're not allowing multiple things to share. So this happens to cause problems in things like vector, because for example, in vector sorting, there might be a comparison function that takes in two of these things, pass by value, that's a copy that's going on, and you're not allowed to do that, and so you can't compile it. So this auto pointer can't really work well with containers. So in C++ 2011, they added a whole new suite of templated smart pointers that have different behaviors that can kind of work more nicely with other types of things. So they got rid of this auto pointer and added in unique pointer instead. So in standard, there's a unique pointer, you say what it holds, and then you grab the resource from wherever, build a house or a new something. And if you own that pointer, you can modify the house. It has some other additional syntax. There's a new move thing. Move says this thing is allowed to be assigned to something else. It doesn't actually do the move. It's the assignment that doesn't move, but you basically have to say, if I want to move this thing into here, I have to tell the compiler that's explicitly allowed. The reason for this is we'd still like to be able to, take an object here, put it under this name, and so on, but we don't want to do it by accident because only one thing is allowed to own that resource. And so you have to be explicit and say, yes, I definitely want to let this happen at this point, and then it can happen. But you can't just sort of do it accidentally and pass a value or something like that. All right, so unique pointer, the idea is it's a pointer to an object, and only one pointer at a time can point to that thing. And the advantage there is you don't have questions about it. If you're a unique pointer and you're done with it, you better delete it because no one else can have a reference to it. You have to turn raw resources into unique pointers or just make unique. Anyway, it has a lot of syntax associated with it, but again, the work to do it is what makes it safe to use in this context. Then there's a shared pointer. Shared pointer is more like what we think of like with a Java reference. So if I have a Java reference, if I have an object in Java, multiple things can reference it, right? And it counts up how many people are looking at it. And when those references go out of scope, it subtracts it from the reference count. And when the reference count is 0, it's available for garbage collection. So shared pointer is sort of the general use pointer that is smart. It knows when the underlying resource should be deleted. You don't have to delete it yourself. So you knew a resource, you give it to the shared pointer. Other shared pointers can also point to it. You can pass it around to functions, do what you want. And eventually, when everyone's done using it, it just goes away on its own. So this is exactly like essentially a Java object with Java reference. So if you want to put principles of Java, just use this all the time, right? And people say, there's a slight performance penalty to it because it's more than a raw pointer. But unless you're doing, again, some game engine that needs to run super fast or something, if you're ever tempted just to take a pointer and assign it to some new something, just don't do it anymore. Use a shared pointer and it will handle memory management for you. You will no longer crash all the time. A weak pointer is sort of like a shared pointer, except that you can't really use it until it checks to see whether or not that resource is still alive. This comes into play, well, let me just draw a picture. So let's say we have a class person, and in here we're doing a shared pointer to another person, partner. All right, so we have a class, and in the class you have something, you're associated with another person of some kind. And in your main code, you make person 1, and you make person equals a new, equals a shared pointer of a new person, something like that. Person 2, same kind of thing. And then I say P1 partner for P2, and P2 partner for P1. So at this point we have person one, well, not person one, we'll do person one, person two, and they point to each other. And then P1 points to person one, and P2 points to person two. If this P2 goes out of scope, there's still this reference to P2 from person one. And if P1 goes out of scope, there's still this reference going here. So these can go away. These objects still won't go away because they still have a reference count from their shared partnership going on. And so we can't actually access this anymore, but we can delete. I mean, it's still not going to go away on its own because there's a little circular reference going on here from this kind of thing. So a shared weak pointer is used to break this ring, this cycle. So if we have P1, shared pointer, P2, shared pointer, if these are weak, and this is a weak reference, then when these all go away, these can go away. It'll basically check and see, it's not being used anymore from this those pointers there. So if you ever have these situations where you have objects of a class like referencing other objects in the class, you often want to use these weak pointers to make sure that they're not going to just become self-sustaining by themselves.
If we had a shared pointer and they were referencing each other like that, would the compiler catch the error?
It's not an error, it's just that saying it's never going to be, the reference count is 0, and so it's never going to go away.
So we would be aware of it.
You wouldn't really, yeah, it'd be like a leak, but a leak is not the same kind of leak you're used to. It's like a shared pointer, persistent, shared pointer leak or something like that. I'm not sure, now that I'm sort of saying this, I'm not sure why does this work in Java? Like, why does it not get stuck in this kind of, anyone? So if I have a person in class with a person data member, and I reference another one, is that ever going to go away? Like, anyone know how it works? I haven't thought that carefully about Java doing that, but all right, how do you think about that? So in some ways, when we redid the try assignment, we used map instead of no pointer. One could also have chosen to use these kind of shared pointers or unique pointers as well, and then not worried about resource management on your own because these wrappers would control that resource for you. Maybe we should have done both ways and seen which one we liked, I guess, or something like that. We're not really doing a lot of pointer stuff right now, so we're not really practicing this in some sense. But I guess in your like the sprite editor assignment, again, if you're making a pointer or something and it's holding an object, think about figuring out how to use one of these things instead and see if it makes your life a little bit easier. So that auto pointer's gone away, and now there's these three flavors. Unique pointer, if only one thing should be referencing an object, use unique pointer. And there's explicit mechanisms to hand it from one pointer to another. Shared pointer, you can assign and copy like crazy, and it just tries to wait until there's nothing else referencing it before it destroys it. And then the weak pointer comes up in certain kind of slightly edge case scenarios where things reference themselves. All right. So we are concluding the planning phase of the sprite editor. And again, the goal is that you put some thought into it. You've kind of done some designing, some architecting, thinking about how classes get arranged. And now we're into the implementation phase. So let's talk about that a little bit. All right, so this is going to come up pretty fast, right? A week and a half, essentially. So almost 2 weeks, really. But 2 labs from now, we're going to present in lab your working, interesting program to myself, some TAs, and whoever else is in that lab. And I'll have a sign-up sheet, like 5-minute slots, 6-minute slots, whatever it turns into, and you can put your team name on those, so you know when you go. But that's our goal, right? So there's a repo invite, kind of like for the other assignments. GitHub Classroom. Someone should accept it and then add their team members to the repo. I'm saying there's 2 code release dates. There's nothing really, I don't have any punitive action particularly about this alpha release, but basically the Thursday, a week from now, Thursday, we have a little bit of time for you to set up your laptops and have people walk around and just see what you have work for. And they can a little worksheet to say, hey, this is a cool feature or not. I'm not really expecting that much to be working, but hopefully something you can hit play and something will pop up, and maybe you can click on some pixels or load some, do something at least, right? This is just really an effort to have you. This next week is not just like take time off and don't think about 3505 at all this week, right? You should be putting some time in as a team, trying to get some code started. You need to make some progress, or it's just going to go badly 2 weeks from now. So think about this having something for the 31st that does something, right? Maybe you can't save anything yet, or you can't do certain kinds of things. That's okay. Just some core element runs. Tuesday before the lab, midnight is when the code should be finalized. And again, you have a choice. You can use our common virtual machine as a platform. If you build for something else, please add some sort of README. If you have some external library, make sure we can just download the whole repo. And if we're on a Windows machine for a Windows build, we can just kind of say go, and it should run without us having to do a bunch of installing and stuff like that. So in the repo, I want you to have whatever else you had to add to it to make it work. You need a code style document. So you're writing code as a group. Your code should be consistent. It shouldn't just be one person's code and another person's code, and it all looks kind of different, and you keep fighting each other and so on. So this should be ready by the lab next week. And it's just like a page saying, here's what I think the code should look like. It's really just about the visual appearance of the code, right? We're going to have names that look like this, camel case, lowercase, first letters is capitalized for classes and lowercase for data or something like that. Look at these examples here. So nothing too complicated, but just put someone in charge and say, this is the person we're going to follow, or fight about it for a couple hours with each other and decide, how you want spacing and all that kind of stuff to go. And then for the final assignment, every source file should be checked by someone who didn't write the source file. All right, so you go through, just check it against whatever things you say about the style guide to make sure it matches the style. So this whole thing at the end should look consistent. That's a very common requirement in larger projects. You need a short presentation of your product. So on the lab sessions, you just give a presentation. Largely that should be a live demo of what's going on, right? Yeah, that's really it. You should, at some point, go to the lab and make sure we have a laptop and plug in there and can project. We don't have time to mess around watching you fiddle with stuff and have it not work. You should produce an example sprite produced by your system. And my one thing I'd say for your live demo is it's nice if you have a sprite that looks like something. So it shows the power of your system as opposed to just like my blobby circle face that I demoed really quickly. With this. It doesn't have to be elaborate, but just make someone spend 10 minutes poking the pixels and make it look like something kind of nice. You should submit a short video showing your editor in action. Like other times, just basically something for us to reference in case things go haywire and we have a hard time running it or making sure. And you should try to make sure to show most of the main features. So just kind of quickly say, here's how we do this, here's how we do this, here's how we do this. I'm sure a minute or two is plenty long. At the end of the implementation here, I'll be sending out a Google form, some sort of little questionnaire, just asking some questions about how your team performed and how you performed on your team and how each individual person performed on the team. those are important. We actually use them quite a bit in final grading. And again, if everyone's pretty happy with how your team went along, we don't have any real problems with it. But if one person was like, I'm the awesome person, and everyone else is like, this person never showed up and we hate them, then we dig a little deeper and see, try to figure out what happened. And then it affects your grade. So when I ask for those, please hit those in. And then, like next lab, we'll kind of be checking on some aspects of how things are going, sort of a halfway point, and making sure you're making some progress. So you're going to submit to GradeScope. It's just as a mechanism to hold this stuff. A folder with those materials and your repo, where your repo is. And we're going to evaluate this on the project quality and features. And then, your presentation. So these are the group aspects, right? And then your individual contributions. And again, as long as people are all within some, some range of effort within each other, that's all basically good. It happens on teams, right? But if your contributions are low, you'll kind of pull yours out and grade it differently than the group on your team. And then this evaluations from how you think you're doing and how your teammates think you're doing. And then finally, meeting the goals of the planning phase. So I'm not trying to discount that. I'm just trying to say that those of you who are worried about us saying, you said your sprite's going to be up to 100 by 100 pixels and you decide to go 128 by 128. That's an F. That's that's like the bottom of our evaluation, right? It's not a big deal. The main thing is to get something at the end that you're proud of and that looks nice. Hopefully, looks like something that someone designing a sprite would want to use for at least to some amount, and it seems to be solid code. I would also suggest thinking about this again as an opportunity to add something to your portfolio for later interviews and job hunts and so on. And so if you do a nice job, certainly spend a little time making it look good. This is something you can be proud of, and hopefully you include it on a resume or put it on some GitHub document that shows stuff you've done. And I think that again that's a lot of value to show that you worked on a project of a certain complexity and size, and you can describe your role on it and so on. So don't just think of this as something, again, you're getting through to get through 3505. It's something also that is something that you can use as a selling point for yourself in the future. And hopefully, if you do a little extra work there, it might go a long ways for those kinds of things. So, and all these things that are sort of these sub areas, like, hey, during lab, we're going to be looking at the style guide thing and looking at a piece of code you had referencing the style guide. I'll remind you before the lab saying hey, don't forget, tomorrow we're going to be doing this activity, looking at the code style guide. And hey, don't forget, this Thursday, we're going to ask you at the end of the class to pop up your laptop and let people just take a look at how things are going. So, instead of making 10 different assignments here with each little subcategory, was kind of, just a big project, and don't worry about it too much. Okay, questions. I need to make you an example sprite file thing, the JSON DLE.
So does our cube sprite area have to work on Linux and then Windows and the Mac too, or does it only have to work on Windows?
It only has to work on one thing. And it's easiest if that's on the Linux. But if you're all Windows people and you're all, don't want to mess, you all have terrible VM setups and you're going to stick to Windows, just say, hey, in a README, say we built this for Visual Studio 2017 on Windows, and we will pop it open like that. Now, I'm guessing that not all of you are going to have the same machine, so that's the outlier case. The easy case is you're going to work on the VM. Anything else? I think the main thing is here, again, try to get your team to put in, 30 minutes a day for the next week or something here and make some progress, right? And find a way to communicate, use GitHub, use Slack, set up some sort of channel that you're all on, and just ping each other every once in a while and make sure something's happening. So there's no project manager, we don't have a manager for you guys, right? You're all self-managing. And you just let it slip until next Wednesday or something, and then it's this speed run trying to get the sprite editor to work. It's going to be harder. It's, a little bit of effort now will go a long, long way. That's all I can suggest. Please just do it. All right, now I want to give you time to hopefully finish up your documentation stuff, talk to your team, see where you're at, maybe plan out the next week as well.